Welcome to today's webinar. We've got some people joining the session right now, so we'll get started in just a minute. But just while we wait, my name is Carol Ann. I am your webinar support for this morning.
Yeah, I'll give that a closer look too.
If you have any questions, please go ahead and leave those in the chat for Eric or I. Eric is going to get started in just 1 minute. Thanks again, everybody, for joining us. We are going to be putting everybody on mute for the presentation, but if you have any questions later on, we can possibly unmute you to ask those to Eric in real time, but please leave your questions in the Zoom chat, and we will respond to questions at the end. So we've just got a couple more people joining us, so we'll just wait another minute, and then we'll get started. Very excited to have everybody joining us today. It's on the registration list. We've got some people from afar joining us, so thanks for joining us in the evening. All right, Eric, that takes care of everybody in our waiting room. So if you are ready to get started, go ahead. And again, if anybody has any questions or concerns, please go ahead and leave those in the chat, and Eric and I will take care of you.
Hello, everyone. Thanks again for joining us. Appreciate everyone taking their time out of their schedules to take a look at this. Hopefully you'll learn some things today about some pumps, CIP versus COP. So as Caroline mentioned, please leave any questions in the chats, and we'll catch those and answer all those we can at the end of the session. I'm going to start sharing my screen now so we can start the presentation. Okay, so our topic today is going to be getting the most out of your pump in both CIP, COP, clean out of place, and CIP applications. I'm the Southeast Regional Sales Manager for Uniblock Hygienic Technologies, based out of Atlanta, Georgia. I've been with several major manufacturers of components and equipment in the food manufacturing industry for over 29 years now. So I have a lot of experience in pumps, valves, heat exchangers, and other components used in the sanitary and food processing industries. So our goal is what we can kind of teach you today, what you'll learn today. We're going to talk about the regulatory requirements in the food and high purity industries, CIP versus COP operations of components or pumps, CIP versus COP load pumps, design considerations for these different types of pumps used in these applications, pump selections, and some kind of maintenance tips. So first, we'll start with the standards and regulations. Some of the key governing bodies is FDA, the Food and Drug Administration. We have the FSMA, the Food Safety Modernization Act, the USDA, which is the U.S. Department of Agriculture here for the U.S., for dairy and meat industry. These bodies kind of guide you, I guess, how to grow, pack, and process, of course, is the important part of our presentation here today, of the importance of that. The equipment design, obviously has to be sanitation and designed for food contact or high purity contact. The other guidelines we follow are 3A, which is the U.S. organization, and the very specific section of 3A is the 21 CFR Part 117. It's good manufacturing practices, HAZOP, risk-based preventive controls for human food contact and consumption. And why these are so important is we have a couple examples here. There were 8.5 million pounds of chicken recalled back in 2021 due to listeria. So obviously the equipment designs is to help prevent this. Also, there was $8 million recall for salmonella in the peanut butter industry back in 2016. So very, very important for manufacturers of these components to follow these guidelines. So cleaning and sanitation, that's also governed by the 3A 21 CFR Part 117. It goes through the process, allergen relation to it, sanitation, supply chain, obviously recalls and things that can come from this. I'm sorry?
You're all good, Eric.
Okay. So an additional part to the 117 is the point 135, which is the preventative sanitation control. So obviously that's preventing cross-contamination and contact cleanliness of the food contact surfaces. So we'll get into a little bit more on that in some further slides. So obviously some definitions for you to see what cleaning means. Obviously the removal of soil particulates from the surface by mechanical, manual, or chemical methods. Obviously sanitizing, treatment of a clean surface with a chemical or a physical agent to destroy disease-causing organisms. Obviously disinfecting, the destruction of all vegetative state organisms. Sterilizing, which is complete destruction of the organisms. And then the surface dirty, of course, is the surface that's not clean. Further on cleaning and sanitation, we like to use the acronym TACT WINS. It's very important that when you're cleaning food process equipment and components and piping, that the most important is the TACT, the time you takes to clean the equipment, the action, what we call the mechanical action, which is the velocity that the liquid needs to flow through the piping to get the mechanical action required to clean it. Concentration would be of your cleaning solutions, what type of concentration you're using, based on obviously the type of liquid products you're running through and what type of soiling it has to get that clean. And then a lot of times, especially in the U.S. market, is the temperature. We use heated solutions, cleaning solutions, water and things to help aid cleaning as well. And then obviously the water, the individual, which is a person, obviously nature, what you're disposing and putting down the drain is important. And then obviously the surface finish at the end has to be what is required to be cleaned. So that's some of the important parts of the cleaning and sanitizing processes. There's two types in our industry, the CIP, clean in place, and then we have COP, which is clean out of place. One of the ways of cleaning is foaming, which we see in some industries, and also spraying, which obviously is a manual process of cleaning. So that's kind of the kind of review of the cleaning and sanitation processes. So we'll start with the CIP. So clean in place. One of the most important factors of this chart we show to the right, that's the kind of the general guideline of the velocity that you need to have through your different size piping to create the mechanical action to get the surface cleaned. So the guideline is 5 feet per second. Some industries require a little bit more, 5, 6, 7.5 feet per second. Other industries, depending on the type of soiling, can be as low as 3 feet per second. And then we show the corresponding flow rate through the piping system that you need to push through with the CIP supply pump to make sure that that mechanical action is reached. So some of the advantages of CIP, of course, is it's an automated cleaning, very repetitive. It's going, once the system is set up, you're going to get the same type of cleaning every time you run your automated CIP system. There's no removal of piping, so no mechanical labor involved to take things apart and put things back together. That also reduces the labor cost, of course. It's typically a faster operation because it's automated. It reduces the equipment damage from disassembly and reassembly. So those are some of the things that the big key advantages. There are some disadvantages to clean in place systems as well. Number one is it's a high capital expense. The equipment you have to buy to automate, have sensors, have flow meters, things like that to put that type of system in can be very expensive. It requires a separate CIP supply pump, so there's a separate pump, tanks, and piping that are required, so it's a whole another set of equipment as well that's put into your plant, and sometimes there's no space for that. Trainability is very important. So sometimes if the system is not designed correctly or the equipment used is not oriented correctly, you have pockets of water left in your system, so that can be a disadvantage for automated CIP systems. There are multiple types of steps of processes. There's what's referred to as a 3-step CIP system, a 5-step CIP system, or in some cases, 7-step CIP systems. All of those, of course, take more time as you add the steps, so that can be time-consuming sometimes, depending on what your process requirement is. The other disadvantage is calibration required for instrumentation. For it to be automated, you have to sense the concentration of chemicals. You have to obviously meter the flow rate, so you know what your flow rates are. So that equipment has to be calibrated on a regular basis to make sure that the system's operating correctly. The next type of cleaning is COP, or clean out of place. So here's some advantages of cleaning out of place. It's a manual cleaning, physically removes the soil that harbors dangerous pathogens. So because you're visually seeing it and you're manually cleaning it, you know it's coming off the equipment. There's no cracks and crevices because you're pulling things apart. You can see again behind certain pieces, or get by removing them, you can get to the harder to reach areas that sometimes the CIP system has to reach, through chemical action. There's a lower capital expense. Obviously, you don't have to buy the CIP system itself, the tanks, the pumps, and the piping associated in instrumentation for the automated type system. There's no need for a separate CIP supply pump, tanks, the equipment we just talked about. And again, because you're manually disassembling it, there's no trapped water or pockets of water left in the system. It is a simple process. You don't have the instrumentation to monitor and control, so that makes it easier, as well as no calibration for that equipment either. However, there are some disadvantages to COP applications. There is a potential for cross-contamination from workers. If you're putting a piece of equipment down or touching against another piece of equipment and then putting it back together, you potentially could have contamination issues. There's a higher labor cost. Obviously, you're going to have people manually doing it, so they have to, take the time to take things apart. So the number of people obviously takes more in a COP system than it does in a CIP system. Training, obviously, you have to train your sanitation staff and/or technicians or maintenance, whoever's going to be involved in that disassembly, reassembly of the equipment. You also have to design your piping systems where it can be disassembled. So you have different shorter runs of piping, connections and things like that on there that allow you to disassemble it in manageable pieces of the equipment. So that can be a disadvantage. And then the safety concerns, lifting things, moving things up high or down low, sometimes it's heavier equipment, so safety concerns of people getting injured. So now let's talk a little bit about the clean in place design for the equipment itself. Obviously, specifically here, pumps. So these are going to be, obviously, two pictures you see here are rotary low pumps. So selecting the right pump, the pump itself has to be of a hygienic design to be cleaned in place and not disassembled for cleaning. So that means there has to be crevices that are free or easy to be cleaned with water solutions getting inside the pump. So the design has to be that way. Also, when rotary low pumps, the rotor design and the seal design is very important if you know you're going to be cleaning a place. Materials of construction are very important. It all has to be, of course, food grade compatible. Most commonly used stainless steel is 316L for sanitary components and equipment. And the surface finish of that material has to be of a minimum of 32 RA, so that the surface finish can be cleaned, automated by CIP method. Also, you have to make sure any elastomers in the pumps that are manufactured are FDA compliant, food grade compliant. Most commonly used is EPDM and FKM. FKM is a generic term for Viton, which is most commonly used. And then your cleaning solutions also have to be compatible with your elastomers. You can choose elastomers that will not degrade in a short period of time. Another factor important on the design of the pumps for CIP applications is the clearances between the rotors and the rotor housing. When you're doing a process that is at a lower temperature than your typically elevated temperatures for your cleaning solutions, there's expansion and contraction that happen in the pump itself and the components inside. So the spacing clearances between have to be designed to allow for that expansion, so you don't lock up a pump. The process temperature versus the CIP temperature, if it's a drastic change, you have to allow for time sometimes to cool and heat to be able to keep the equipment from not performing correctly. Also, the CIP accessibility. You have to have ports and paths and ways for the CIP solution to get inside all areas and cracks and crevices of the pump to get clean. So that's important that the equipment's designed to allow for that. And then the efficiency. You want it to be an efficient pump for the application so that you can make sure it cleans without having to take a long period of time to do so. And then we talked earlier about the pockets in the systems. So the port orientation and specific into pumps, you want them so that they will fully drain. So there's no pockets of water left in the pump equipment itself. And the typical validation process for this is a swab test. So once you run a CIP process through the equipment, you go back and swab test it to make sure that it did get cleaned properly, and then you can ensure that the process you used is cleaning the equipment the way you need it to be cleaned. Continuing on, when the CIP, the crevice-free features of the pump, this particular application is on a peanut butter process. Use a tri-lobe rotor, and the designs on the front, you can see there's slots in the what we call the rotor nuts, or in this case the rotor bolts, to allow CIP solution to clean in there, so there's no cracks and crevices there. And you use O-ring design so that you don't have any void areas behind O-rings that's hard for the CIP solution to get into. The most critical part of a rotary low pump in getting the clean on the CIP system is behind the rotors themselves. There's a seal area in there, mechanical seals used, and there's has to be designed so it can efficiently get CIP solution into those areas and get that clean. So this is an example design option that we use on some of our rotary low pumps. It has a special CIP slot machined into the housing to allow CIP solutions and water and cleaning solutions to get in behind there and flush things out in an efficient manner. So now we'll move to clean out of place. So here's some of the key features of clean out of place equipment and pumps in the industry. So obviously the same features of it has to be of a hygienic design so that it's used for food applications. You have the proper materials used. Again, the 316L stainless steel is the standard. There are some other materials that can be used in COP applications, non-metallic, we like to say, polymer materials. Obviously, they have to be FDA compliant. They also have to be typically X-ray and metal detectable. So if a piece does break off of a non-metallic component, it is detectable somewhere down in the system. We have the same elastomers typically used on COP pumps versus CIP, the EPDM and the FKM, and obviously in a food grade FDA compliant material. The temperature changes. This is less critical on COP applications. The process temperature versus the IP temperature is not a concern because you're going to dismantle it and not automate the cleaning process for that component. Drainability is less important when it comes to COP because you're going to manually take it apart. So you can get all the water and things out. So that's less important when it comes to COP as far as the design of the components in the piping system. The disassembly assembly, we have pumps designed for no tools required to take them apart. Again, if we know it's going to be a COP application, we know it's going to be taken apart on a regular basis, typically daily. So we want to make it as easy as possible to take apart, so no tools required. The other part is fewer parts to have to handle when you're taking a COP pump apart. And of course, the safety part. You want it to be safe to take apart, so there's no risk for injury for the sanitation. So here's an example of a uniblock pump that's designed for COP applications. As we said, no tools required to take it apart. There's fewer parts to be dismantled and removed, which also makes it easier and safer. And then we're comparing our pump to another type of pump technology in the food industry that can be taken apart and hand cleaned, but there's many more components to be able to do that. So getting that apart in an efficient manner putting it back together correctly and quickly can be more challenging if the pump is not designed specifically for COP applications. Now we can compare a CIP pump, rotary low pumps of the same type. One's designed for CIP applications and the other one's designed for COP applications. So obviously on a CIP application, you're not taking the pump apart. It's going to be automatically cleaned, so there's no tools required to do that. And then there's additional O-rings that are used in a CIP pump and rotor bolts, because again, you're not taking it apart on a regular basis. When you compare that to a pump that's designed for COP, we minimize the number of parts that have to be handled, and obviously no tools to take it apart as well. So that's the big advantage of a pump designed for COP, is the minimal number of parts to remove, and the biggest part is no rotor bolts. So you don't have to have the tools to disassemble rotor bolts to take rotors out of the pump. So this is an example of a clean out of place pump. I've got a video here I want to show that shows this pump coming apart. So we have developed a quick strip hinged front cover, a safety swing arm we call it, that's designed to swing the front cover off so it keeps it off the floor. Also, we have spacers because we don't have rotor bolts on the pump. So we have spacers that keep the rotors from hitting the front cover. Here's the swing arm closing, the wing nuts being put on, so no tools required. Inside there's no front cover O-ring for very viscous product applications. It will not leak out the front. And then makes it quick and easy. There's a sign of the wear rings, the spacers inside. And again, the design is to keep the no rotor bolts so that we can disassemble quickly and easily, keep the cover off the floor as it swings open. So the next slides here, we want to talk about some general tips and tricks when it comes to using sanitary rotary low pumps. If you can schedule preventative maintenance, it's very beneficial. So you're repairing the equipment to help ensure there are no downtimes during a production run. A lot of plants, some plants can do this, some plants can't. It all just depends on their process and their staffing, and how often their production equipment is not running. Some of the other things you want to look for is you want to do regular lubrication for your equipment, your pumps. You want to listen for abnormal sounds the pumps may be making. That's typically a key indicator that there's a failure about to happen. Obviously, you don't want to dry run pumps if you can prevent that. That can only cause damage to seals and other components in the pump if it's done for too long. You want to look for leaks. A lot of the sanitary pumps are designed so that if there is a seal failure, you see a leak to the atmosphere. That indicates that, yes, there's a leaking part. The next opportunity I get to repair that, I need to get that pump out of service and get it repaired. And you also, when you're doing COP type applications, as you're disassembling a pump, you're looking for galling or any signs of abnormal wear that may be happening inside the pump. There's a coupling alignment for the pump and motors in most rotary low pumps. You can hear sounds from that, so you want to listen to that, as well as do a visual inspection if you see anything wrong there. Rotor clearances. You want to make sure your rotor clearances are checked on a regular basis, especially on COPs. You can visually take it apart and see if it's hard to take apart or getting binding in the pumps. And then torque and tension. That can happen when you're putting a pump back together. You want to make sure there's proper torque on some if required, and then the same amount of tension on certain components. So here's a quick little video of an example of a pump that is has a poor alignment on the coupling, which is called a jaw style coupling, typically used on rotary low pumps. You can see the movement, slight movement there of the Copeland guard area of the gear reducer toward the pump. One of the things that Uniblock does is that alignment issue can be eliminated. It can be engineered out, if you want to call it that, or designed into the equipment. Here's an example of a video here that shows we call a compact design. We eliminate that requirement of having to align the shaft of the pump and the gear reducer by making a special adapter that goes from the pump gearbox to the gear reducer of the motor that self-aligns those two shafts. It still uses a jaw-style coupling, but now you don't have to worry about the alignment because the adapter automatically aligns the two components together. It also acts as your OSHA guard as well, so you can eliminate the doghouse style OSHA cover that you have to typically do on a base mounted style pump. So Uniblock, we have a pump reliability checklist. You can go to our website, uniblocktech.com. It's a pump reliability checklist. It goes through some good information on what things you can check and look for on your pumps, and also to help maintain and prevent premature failures on the equipment. So that's a good resource that you can take a look at on our website. We have a few videos here. I'll play one for you. This is a case study. All these videos can be found on our website as well. We have a resources tab, and under resources tab, we have videos, we have white papers, we have obviously product documentation, maintenance manuals, a lot of different products that are very useful for finding information. So I'm going to play a quick video here.
Eric, I think it may be playing in another screen.
Say that again, Caroline.
I think the video is playing on another screen.
It linked. Let me stop that.
Everybody will be getting a copy of this deck, so you can watch the videos at your leisure.
Go back to the else went to another screen on me. Bear with me for just a minute. I got to get back to the presentation.
While Eric gets back to us, if anybody has any questions, please go ahead and leave those in the chat. We'll be answering some questions in just a few more slides.
Okay, we're back now.
Yep, we're back.
In addition to the videos that are on our website, we also have several blogs. We have a blog for the poultry processing industry. We have a blog for the enhancing safety in equipment. And we have another blog as well. So one of the other things that we have here is Uniblock is more than just rotary low pumps. We do offer other pump technologies, several different brands. We have Flowtronic AODD pumps. We have Hygienitech, what I call pump complementary products that are PRV valves, check valves, strainers, sight glasses, and other components that complement different types of pump technologies in the industry. We have drum pumps, which are our standard brand drum pumps for pumping different food products as well as non-hygienic products as well. We have two technologies. We have centrifugal drum pumps. We have progressive cavity drum pumps, and we have different motors as well. We have electric motors and air motors for those. And then on our Uniblock brand of pumps is our rotary lobe pumps. We also offer gear pumps for hygienic applications as well under the Uniblock brand name. So Uniblock Hygienic Technologies, we're proud to have offered equipment to the hygienic industry for 30 plus years with a very good track record. Everything I've presented we can summarize here, and that we want to offer safer than ever equipment for the food industry, fewer parts and greater detectability, help ensure the highest level of food safety with the ability to clean in a short amount of time, 20 minutes, where it's commonly compared to roughly an hour for some other brands of equipment. The added benefit of our safety swing arm makes disassembly of the cleaning easier and safer than ever before. Swing arm supports worker safety and efficiency as well. We have increased production. Quick strip design offers a simple, quick, easy way to disassemble a pump for COP applications, which also reduces wear and tear during a manual cleaning process. We want to improve food safety, no plastic parts, O-rings, rotor bolts, rotor nuts, things like that can get into foreign materials getting into your product. And then obviously lower costs. We want to save worker staff. You want to have food safety. So you have a worker and safety combined with decreased downtime equals a lower cost of ownership. So the cost to operate one of our pumps over a year's time can be lower than the industry standard or average. So feel free to ask me about any of our flow control products or brands. I'll be glad to give you more information on those, as well as on our website. We have plenty of information and resources there as well. So now we'll go open up to some questions. Any comments? Feel free to share those with us in the chat, and we'll be glad to answer them for you.
Eric, we've got 4 questions for you. I just put them in the chat for you.
Okay. Take a quick look at that here. Let's go to the first one here. So we have one that says, would like to talk on twin screw pumps. We can talk about twin screw pumps. It is another technology that is available in the food industry. It's somewhat newer technology that's come probably in the last 10 to 15 years to the U.S. market. There are some benefits to twin screw pumps. The biggest benefit is it has a wide speed range compared to rotary lobe pumps, which allows that pump to be used in product applications for pumping product, which are typically viscous products at slower RPMs. And then you can also use the same pump to speed it up to pump thinner CIP solutions so that you can use 2 pumps at once. You don't have to have a separate pump for CIP applications or CIP duty for that. So that's the difference in twin screw pumps. So we have a question here. Same thing at twin screw pumps. We had that again. So as far as resources to rotary lobe pumps, you can reach out to, we do have RSMs, regional sales managers across the United States. We have currently 4 RSMs that can help you in different regions. We also have resources on our website. If you go to uniblocktech.com and go to resources tab, there's what we call brochures as well as manuals there. You can find on all our different products. We had another question here. Can the pumps you talked about today be easily integrated into existing systems? In most cases, they can. It sometimes requires a slight piping modification to put them in. It all depends on what your current technology is and what your current piping system looks like. But they typically can be relatively easily integrated into existing systems. We had a question here, which pumps can be cleaned in 20 minutes? That would be referred to as our quick strip design pump, which is a COP, clean out of place type applications. Those are the ones that can be manually cleaned in a short amount of time because there's no tools required to take it apart or put it back together. In some cases, in CIP applications, depending on the soiling level, you can clean those also in a short amount of time. If you typically use a shorter 3-step process, they can be also cleaned in 20 minutes. So it could actually apply to both CIP or COP applications. Let's see if we have some more questions here. So we have one here. What is the advantage of a Flowtronic AODD for CIP applications? So on our Flowtronic pump, that is an AODD, air-operated double diaphragm pump. There's two benefits there. Number one advantage is the design of the pump is it's only held together mechanically with one nut. So if you remove the one nut, you can disassemble the rest of the pump with no tools. So it comes apart quick and easy in less than 1 minute for disassembly, and then it can be cleaned. That's one feature of our Flowtronic AODD pump. The other feature is we have an option we can add to the pump to the air side of the diaphragms. We call them diaphragm support plates. It's the only AODD pump with this feature available. By putting those on, then you can actually CIP this AODD pump like a traditional rotary lobe or centrifugal pump, where you can CIP it in line without having to take it apart. So there's two benefits for the Flowtronic AODD pump when it comes to cleaning. Quicker manually to take it apart and clean, and then also can be automated to be cleaned and CIP'd in place with a separate CIP supply pump, pushing liquid through the pump. Let's see here. Basically, a follow-up question as well. What is the advantage of a Flowtronic AODD versus the CIP application? So we just covered that. And let's see what else we got here. We have a question, how twin screw pumps can run in a wide range when we compare with low pumps. What difference does it make for twin screw pumps to run in a wide RPM level? The difference it makes on twin screw pumps is that when you have thin liquids, you have what's called slip in the pump. It goes between the tolerances we talked about, between the rotor and the housing. Thicker liquids don't slip as much through the pump. So when you have thin liquids, to compensate for that slip, you have to speed the pump up. So to compensate for slip and get the same amount of flow with the thin liquid, you have to run the pump much faster than on a bit more viscous product. So that's why you have to have a large speed range on twin screw pumps, is to allow you to pump thin liquids, turn the pump speed up, and on thicker products, you can run it at lower RPMs. So that gives you a wider range compared to rotary lobe pump. In some applications, rotary lobe pumps can do the same thing. You can actually pump the CIP solution through the pump at the proper velocity through the piping to get your piping clean. We talked about the 5 feet per second to get the proper mechanical action to get the piping clean. In some applications, rotary lobe pumps can do that. If the product and CIP speed ranges are closer together, then you don't need that large speed range. You can do that with a rotary lobe pump as well. Let's see if we have any other questions here. I think that covers all the ones in the chat. We're definitely open to more questions, or if anyone has anything else they'd like to address, I'd be glad to do that as well. And we could take some live questions, I guess, as well, if anyone has any questions they don't want to put in the chat.
Eric, while we give everybody a minute to possibly ask more questions, I did just want to remind everybody you will be receiving a copy of this deck and the recording from today, so you can go back and reference any of those video links or any of the information that Eric has shared.
Looks like we did get a new message here. How might the CIP and COP low pump differ in product pumping performance? The performance itself is actually very, very similar. There's very little, really no lost performance when you go to COP type applications. It's more of a mechanical design to allow the pump to be disassembled quicker and easier than it is to leave it assembled for CIP applications. So for uniblock, there's no performance difference between our CIP design and COP design pumps.
All right, it doesn't look like we have any more questions. If anybody does think of anything, feel free to send us a message after the event as well. We will be following up, so you'll have our emails. Eric, great presentation today. Thank you so much. I hope everybody enjoyed the presentation.
Thank you everyone for attending. Again, as Caroline said, we hope you learned some things today and saw something was beneficial to you. Feel free to reach out to us for any follow-up questions or any other documentation or information you may need.
Thanks, everybody. Have a great rest of your day.
Thanks, Eric.
Well, we did get a couple new messages. Let's see if we have anything urgent here.
Everybody's very thankful for you.
Okay. So we did have one quick question here. Are twin screw pumps biotech ready? That's probably meaning are they, the term I use is high purity compatible. Typically your polish or finish on those is as a higher level. And in most cases, they are capable of higher polish and finish for the biopharm biotech industry. So yes, they would be available in that configuration. All right, I think that may be it now.
All right. Thanks, Eric. Thanks, everybody.
Thanks, everyone.